We will learn about light and various phenomena linked with it in this video. Light is a form of energy that produces in us the sensation of sight. Actually, it is a miracle that has happened to all of us, along with another wonder, which is our eyes. Light helps us to see beautiful and colorful world around us. So let's know more about it. Light always travels along a straight line path, which is called as rectilinear propagation of light. Normally we cannot see this straight line path, but sometimes due to Tyndall effect we can see the straight rays of sun coming from behind the clouds. Even though we cannot see the rays of sun mostly, still we have evidences for the rectilinear propagation of light, and these are formation of shadows and occurrence of eclipses, which are only possible if light will travel along a straight line. About the nature of light, there was a controversy for a long time. Many scientists believed in wave nature of light and some others believed in particulate nature of light. Now we have accepted a theory which suggests dual nature of light. Means when light propagates from one place to another, it does so in the form of waves, and when light is emitted or absorbed from a surface, it does so in the form of particles called as photons. On the basis of particulate nature, we can explain reflection and refraction phenomena, and this chapter is all about these two phenomena we'll be studying in detail. And on the basis of wave nature, we can explain the phenomena like diffraction, interference, and polarization. You may be aware that there are polarized goggles which stop the glare of the sun, and they can be made only because light travels along in the form of waves. Interference is another phenomena. When two waves are superposed, their amplitude increases. It is only possible if light has waves. And diffraction phenomena can also be explained on the basis of wave nature only. Let's consider a ray of light which is moving and it hits an opaque object. Now this cannot go through the opaque object and it cannot bend around the opaque object. So the part behind this opaque object becomes darker and a shadow will be formed here. Consider another opaque object which is very small in size, smaller than this wave. Now this wave can easily go past this opaque object and shadow will not be formed, and this is called as diffraction. If the size of the opaque object is very small, light has the tendency to bend around it. So this can be explained only if light has wave nature. Now we have understood that light consists of electromagnetic waves that do not require a material medium for their propagation. Means light can propagate through vacuum also. It can propagate through a solid, liquid or gaseous medium also. For example, through glass, water or air, light can easily propagate. Speed of light is maximum in vacuum, which is 3 into 10 raised to power 8 meter per second, and wavelength of visible light is 4 into 10 raised to power minus 7 to 8 into 10 raised to power minus 7 meter. We will see a few important terms. Ray of light. It is a straight line path along which light travels. And a beam of light is a group of light rays given out from a source. These can be of three types. If all the rays are parallel to one another, we call it as a parallel beam. If rays are coming from different directions but they meet at one point, it is called as convergent beam. A divergent beam of light starts from one point and it goes in different directions. Divergent beam can be formed if the light is coming from a point source. Source of light is an object from which light is given out. It can be a luminous source like sun or a non-luminous source like moon. On the basis of its size, we can also classify source of light as point source of light or extended source. Point source of light actually does not exist, but we have to make it. So we can obtain a point source by placing a screen having a small hole in front of the source of light, or we can keep the source of light inside a box with a small hole so that light will come out only through that hole and it will be considered as point source of light. We represent point source as a small dot. Stars which are far away from our earth, they appear to us just like tiny dots, so we consider them as point sources of light. Extended source of light can be any source of finite size, and it is represented by a line with an arrow in the upward direction. When light from a source falls on a surface, three things can happen. One, it may get absorbed by the surface, called as absorption, or it may pass through the surface, which will be called as refraction, or it can bounce back into the same medium, and we call it as reflection of light. So first of all, we will see reflection of light, which is bouncing back of light in the same medium on striking the surface of an object. Depending upon the type of the surface, this reflection can be of two types. If the surface on which light rays are falling is smooth, then regular reflection occurs. If the surface is rough, then irregular reflection occurs. In regular reflection, parallel beam of rays fall on a surface, and after reflection they are still parallel to one another. But in irregular reflection, parallel beam of rays fall on a surface, but after reflection they get scattered in different directions. That is why this reflection is also called as diffused reflection. With the help of regular reflection, we can see our image, and with the help of irregular reflection, we can see different objects. We understand that an object is any luminous source of light like sun or a non-luminous source of light like moon. But apart from that, any surface A, which can be a table, chair, tree, stone, animal, humans, etc., if light falls on them, gets reflected and reach our eyes, they are also considered as object. And from here, one more thing becomes clear, that we can see an object only when light reflected from it reach our eyes. If it does not reach our eyes, we will not be able to see an object. For example, during night we cannot see a stone because there is no light, so no reflected light also reach our eyes. Another example can be of black holes, which are the massive mass in the universe, but still we cannot see them. We know they are there, but we cannot see. The reason is all the light falling on the black holes goes inside and nothing is reflected, so they are not visible to us. One more example we can take, that of Harry Potter's gown. When he put on that gown, he became invisible. So scientists are also trying to make a cloth or a dress which does not reflect light. If they succeed, so we can also become invisible one day. Now image. Image is formed when light from an object falls on a shiny surface, which can be a mirror, metal surface, or surface of water. Then it gets reflected and reach our eyes. We will see the concept of object and image once again. This is the source of light. From this source, light falls on this person, gets reflected and reach our eyes. So for us, this person is an object. But light from the source is falling on this person, getting reflected to fall on this shiny surface, again getting reflected to reach our eyes. Now our eyes has some limitations. It cannot perceive the actual origin of the rays. Actually the rays are originating from this point, but our eyes cannot perceive, as eyes can perceive only the straight line path. So to our eyes, these rays are coming from this point. If we extend all these rays backwards, they appear to meet at this point. So for our eyes, rays are coming from here. So we see this object here also, which is the optical illusion and the image. Images can be obtained using mirrors. We will see plane mirror first of all. To make a plane mirror, we'll take a thick sheet of glass and coat one side of it with silver. Silver is the best reflector of light, and it reflects almost all the light that falls on its surface. But silver can be easily scratched, so to protect it, behind the silver coating we will put a coating of red paint also, and our mirror is ready. Silver is a bit costlier, so we can also use aluminium in place of silver. To represent a plane mirror, we'll draw a straight line having a number of short and oblique lines on one side. If a ray of light will fall on this mirror on this side, which we have painted with red paint, light will be reflected but image will not be formed. And if the light ray is coming from this side, then the image will be formed inside this plane mirror. But notice one thing, that light ray will not be reflected by this front surface of the glass or the mirror. It will be reflected, it will go up till the silver surface and will be reflected from there. And this will be called as incident ray. This is the point of incidence where incident ray is touching the glass surface, and this is the reflected ray. Angle between incident ray and normal is angle of incidence, and angle between reflected ray and normal is angle of reflection. And you have already studied laws of reflection of light. Let's revise them quickly. Incident ray, reflected ray, normal at the point of incidence all lie along the same plane, and angle of incidence is always equal to angle of reflection. Plane mirror forms a virtual image, but there are certain other mirrors which can form real image also. Let's see how these two images are different from each other. In case of a virtual image, the rays which are reflected from an object falls on the surface of mirror, and after they reflect from the mirror they appear to come from a point. At this point image is formed, which is a virtual image. Another example in which real image is formed. Rays from the object are reflected, fall on the mirror, and after they are reflected from the mirror they actually meet at a point. Wherever the rays meet, image will be formed there and it will be a real image. We cannot see real image as such unless and until we keep a screen over there. But for viewing a virtual image, we do not require a screen. Virtual image is erect while real image is inverted. So we have seen the differences between the virtual and the real image, and now you can answer this question. How is real image different from the virtual image? You can pause the video to think about the answer, and then you can match your answer with this table. Let's see the examples of real image. Image formed on the cinema screen and image formed on the retina of our eyes. These are the examples of real images. But we have just seen that real image is always inverted, but we do not see inverted image in both these cases. Actually, on the retina of our eye, inverted image is formed, but when brain perceives this image, it perceives it in the erect form. And on the cinema screen, when the rays are projected, they are projected in the inverted form, and as a result, they appear erect to us. And the examples of virtual image are the image in the looking mirror. So let's now see what are the characteristics of the image formed by a plane mirror. It is virtual and it cannot be obtained on the screen. It is always erect. And the image which is formed in the plane mirror, the size of the object will always be equal to size of the image, and the distance of object from the mirror will always be equal to distance of image from the mirror. Another important characteristic of this image in a plane mirror is it is laterally inverted, which means that if you stand in front of the mirror and lift your right hand, your image will lift its left hand. You may also have noticed that ambulance on an ambulance is written in the laterally inverted form, so that if somebody is seeing from the rear view mirror of his vehicle, he will perceive it in the normal form. A few more important things about plane mirror. It neither converges nor diverges a parallel beam of light. Focal length of plane mirror is infinity and magnification of plane mirror is +1. 1 means that size of object and size of image are same, and plus sign here means that image is erect. Now we have learnt about the plane mirror and we can answer these questions now. An incident ray makes an angle of 55 degree with the surface of a plane mirror. What is the angle of reflection? So you can think for some time by pausing the video and then you can check the answer. So answer is 35 degree. I'm sure you have got it right. Let's see another question now. John is observing his image in a plane mirror. The distance between the mirror and his image is 6 meter. If he moves 1 meter towards the mirror, what is the distance between John and his image? Again, pause the video and calculate. So here we see that when John moves 1 meter towards the mirror, his distance from the mirror will become 5 meter and the distance of his image from the mirror will also be 5 meter. So now the distance between John and his image will be 10 meter. So our answer is 10 meters. Now the last question. Now this is the clock which is showing time in the mirror. Means this is the laterally inverted clock. You have to tell the actual time. And I hope you have got it right. The actual time will be 9:25. That is all about the plane mirrors. In my next video, I'll talk about the spherical mirrors. So stay with me and thank you very much.